Good morning, ladies and gentlemen. This is Mr. Rowe. We're looking in Geometry Part B. This is Lesson 1, and we're going to talk about two theorems, the Side-Splitter-Theorem and the Triangle-Angle-Bisector Theorem. So let's take a look at what these mean. These are discussed in the lesson content. So let's take a look at the Side-Splitter-Theorem. It basically says that if a line is parallel to one side of a triangle and intersects the other two sides, then it divides those sides proportionally. What does that mean? It basically means we've got a parallel line right here. These two lines are parallel, and this line intersects these two sides, and these parts are proportional to each other. So if DE is parallel to AC, which we have, then BD, so this section, over AB, this section, is the same proportion as BE to CE. So that is the Side-Splitter Theorem. So let's take a look at an example of how this is applied. So here is our triangle, and we've got a set of parallel sides here, so we know we're going to use the Side-Splitter Theorem. So we're going to set up a proportion with x over x plus 6, and then 9 over 15. So from here, we're going to take our cross products. 15 times x is 15x, and then 9 times x plus 6 right here, we're going to have to apply distributive property to get 9x plus 54. So now we're going to subtract 9x from each side to get 6x equals 54, and then finally we're going to divide by 6 to get x equals 9. So that's how the Side-Splitter Theorem is applied. So there's a corollary to this theorem as well. Now, corollary is just something that comes from that previous theorem or follows from, or something we can use to show something else. So here's what the corollary says. It says that three parallel lines intersect two transversals. You can visualize that because we talked about parallel lines in another lesson. And the segments intercepted on the transversals are proportional. So here's our picture. We've got three parallel lines. So basically what it's saying is that these sections right here are proportional to each other. So we got P is parallel to Q, which is also parallel to R. And so AB over BC is the same proportion as DE over EF. So let's look at how we're applying this in the lesson. So we're going to look at a diagram. This is kind of a cross-section of what New York City looks like near Madison Square Park. So you can see we've got a set of parallel lines here. So we've got 20 and 19th, 20 and 21st Street are parallel lines. These are transversals. We've got some distances here that we kind of figured out. And we want to determine the value of x, the distance of x. So we're going to set up a proportion with x over 236 equal to 269 over 246. So we take our cross products, 246x, and then use your calculator here. 236 times 269 is 63,484. We're going to divide by 246, and that's going to give us approximately 258 feet to go from the corner of 20th and 5th Avenue to 21st and 5th Avenue. So finally, we're going to look at the Triangle-Angle-Bisector Theorem. Let's look at what that says. So we got a ray that bisects an angle of a triangle, and it's going to divide the opposite side into two segments that are proportional to the other two sides. So what does this look like? So here's our triangle. This is an angle bisector. You can see it's marked with the angle bisector here. So these two sections will be proportional to these two sides. So this over this will equal this over this. And let's see how I wrote it. I think I wrote it actually the other way. So if DH bisects EDF, which it does, we can tell by these marks, then FH, that's how I wrote it, FH over EH equals DF over DE. So this section over this section, and then the sides that correspond to those parts over each other. So let's take a look at how this is applied. So we're going to find the value of x in this particular triangle. I didn't mark it, but this is an angle bisector. I should have marked it, but I didn't. So that's an angle bisector. So first thing we got to do is figure out what this section is right here. Well, this whole piece is 6. Well, then this piece right here is going to be 6 minus x, the whole thing minus this piece, which is x. So now we're going to set up our proportion. So this will go to this, the same as this goes to this. So x over 6 minus x equals 6 over x. So you see these sides should be side by side. And these should be side by side. So that's how you're going to set up your proportion. So now we're going to take our cross products. 4 times x is 4x. Then we've got to do 6 times 6 minus x, apply some distributive property there. So we get 4x equals 36 minus 6x when I distribute. We're going to add 6x to each side to get x's on the same side. That gives us 10x equals 36. Finally, we're going to divide by 10, and that gives us that x is 3.6. So I hope this helps you with the side-splitter theorem and the triangle-angle-bisector theorem. If you're still struggling with this content as you work on your lesson, please let us know in the teacher message or make an appointment for a help session.